On this question, I have a weak acid, which is HA, and it breaks down into two things: the positive ion, which is the proton, H+, and the negative ion, or the A-, which we call the conjugate base. So this is an aqueous acid, breaks down into protons and A-, and he's trying to find the Ka for this solution, or the acid dissociation constant. The acid dissociation constant is just the equilibrium constant. And how do you find the equilibrium constant? The concentrations of the products divided by the concentration of the reactants. And every one of these is raised to the power of its coefficient. So the first one is product H+ ions, and you multiply it. You don't divide it. You multiply it by the A-, or you don't add it. It is say here plus, but you will always make multiplication here. And then divided by the reactants, which is A. As long as you have aqueous or gas, you can put this in the equations, but never put a solid or a liquid in it. So H+ concentration multiplied by A- concentration divided by HA. And the second question, I'm trying to find the concentration of OH-. In all such questions, you are just playing by moving between the different values. So what are the different values? The H+, the A-, if you are talking about an acid, concentration of H+ can lead you to the pH and can lead you to finding the Ka of the solution, like we just found it now. So if you have a weak base, so you are moving between OH- and the Kp and the POH. So the OH- can be changed into POH, and POH- can be changed into OH-, and this can be changed into Kp, and Kp can be changed into OH-. This is all regarding weak acids and weak bases. Don't forget that also by this relation, you can change between pH and POH. As pH plus POH, the total of them is equal to 14. So if you have one of them, you can find the other very easily. The base here is a weak base called aniline. So how did you know that it is weak? You see that its dissociation constant is very low, 10 to the power of -10. So I will say that the Kp is equal to the bases over the acids. I'm sorry, is equal to the concentration of the products over the reactants. So C₆H₅NH₃ plus multiplied by the OH- and dividing this by the reactant, which is C₆H₅NH₂. So the products over the reactants, the liquid is not included as it is liquid, and we put only the acids. What is the value that we have? We have 0.36 as a pH. So I can use this to find the OH-, and we can use the concentration of H- and the pH of the solution. So I need to find two things. I have the Kp. From the Kp, I can easily find the OH-. How do you find the OH-? A very important information telling me that these two values are also equal to concentration. So this one is equal to this one. Why is that? Because if you have 10 here, it will be broken into 10 and 10. If you have 20 here, it will be broken into 20 and 20. So these two values are always similar. So I can simply just remove one of them and repeat the other one twice. So Kp is equal to the OH- concentration squared divided by C₆H₅NH₂. So how do you answer such a question? The answering is happening by getting the values and just plugging. So you can just find X, and X will be equal to the OH-. How do you find the X? You have already the Kp. So as I said, I have either the OH- and they give me Kp, or I have the Kp and give me the OH-. So I have the Kp, that's equal to 4.1 multiplied 10 to the power of -10. And that's 2x, which is unknown, squared. And this is divided by the initial concentration, which is 0.36 minus x. So finding x will give me 1.2 multiplied 10 to the power of -5, and this is equal to the OH- concentration. I found the first part of the solution, and the second part is the pH. If you have the OH- concentration, what is the POH? It's equal to 10 to the power of -log of this value, 10 to the power of negative, this value 1.2, 1.2 multiplied 10 to the power of -5. Don't forget, how do you change from H into pH and pH into H, and how do you change from OH into POH? That's by the negative log. But how do you change POH into OH minus? The POH is equal to the negative log of OH minus. So how do you get POH? That's equal to negative log of POH minus. What is POH minus? We just found it out. So that's equal to negative log of 1.2 multiplied 10 to the power of negative 5 is equal to 5.92. What is the relation between pH and pOH? pH is equal to 14 minus pOH. That's equal to 14 minus 5.92. That's equivalent to the answer, which is 9.08. The next question, this time he is asking for the pH. No, the pH is given already. The pH is equal to 0.50 of ethylamine solution. So the concentration is 0.50 and the pH is equal to 12.22. So this is the pH and this is the concentration of the base, ethylamine. Calculate its dissociation constant. In order to find the dissociation constant of Kp, you need the products over reactants. So product, how much is this one? And how much is this one? And this one concentration. He has already given the initial concentration, 0.50. How did you know? He is given the ethylamine initial concentration. So you just need these two. Do you know any of these two? No, I don't know them. But I know the Kp. Or do you have the Kp? No, they need the Kp. So I have given the OH minus, and I need to find the Kp from it. As we said, this one is equal to this one. So we can say that the Kp is equal to the products, which is the OH minus squared divided by the initial one, which is the 0.50. How do you get the OH minus from the pH? Change the pH into H plus. So H plus is equal to 10 to the power of negative 0.50. No, this is not the 0.50 is the concentration. It's 10 to the power of, again, let's write it here. So if I have pH is equal to 12.22, so POH is equal to 14 minus this value. That's equivalent to 14 minus 12.22. Let's do it on the calculator. 1.78. If you want to have POH and you want to find OH minus, that's equal to 10 to the power of negative POH. That's equal to 10 to the power of negative 1.78. Now what is Kp? Kp is equal to this OH minus square. So this value, which is 1.66 multiplied 10 to the power of negative 2, then squared. Y squared, we said it's equal to the concentration of the base squared divided by the initial concentration 0.50. That's the answer, which is equal to 5.5 multiplied 10 to the power of negative 4. So let's have some questions to make sure that you are able to know all the convergence rules in the previous questions. The first question is asking me, what is the correct formula to convert? Convert what? Convert pH to POH. So let's see it. What is the correct formula to convert pH into POH? If you want to convert pH to POH, what do? Do you do pH plus POH is equal to 10, or pH multiplied POH is equal to 14, or pH plus POH is equal to 14, or pH is equal to POH? Of course, we know that pH plus POH is equal to 14. Second question, how do you calculate the hydroxide ion concentration from POH? There are many ways. If you want to find out how to calculate the hydroxide ion from POH, the OH minus is equal to 10 to the power of negative. So 10 to the power of negative POH. Make 10 and make to the power negative of POH. Not positive and not 1 over and not 14 minus POH. The third question is, if OH is known, how do you calculate Kp for the weak base? I have OH already, and I need to find the Kp for a weak base, I will say that the Kp is equal to the concentration of OH minus, but it is squared, OH minus squared, divided the initial base concentration, Now, one more question in the conversions. When I'm calculating the equilibrium constant, so I have a equilibrium constant Kb, why can the approximation initial minus x is equal to initial concentration be used? The concentration is usually very, very small. We dissociate very little, so I can make this negligible. What does it mean? It means that if I have a base concentration of 1, and I have decreased a small volume, it's like saying that I have 1 million. So if you have $1 million and I take $1 from you, then I'm asking you next day how much money you have. You will tell me I have 1 million. You will not tell me I have 999,999. You will say that I have 1 million because I have already taken very much less money from you, and you will say that I still have 1 million. The next question, which of the following is correct method for converting the pH to hydrogen ion concentration? The same thing we did with the OH minus. So the H plus is equal to 10 to the power of negative pH. So it's equal to 10 to the power of negative pH. To calculate the concentration of hydroxide ions at the chemical Kp and the initial concentration, what formula is used? I will say that you want to find OH minus, the opposite. So you said that the Kp is equal to OH minus square divided by the initial concentration. And you need to calculate what? You need to calculate the hydroxide and you need to find OH minus. So you do the Kp, if you want to find OH minus squared, it's equal to Kp, and this Kp multiplied by the initial concentration. But wait, this is only for OH squared, so you want to find OH is equal to the radical of this value. Kp multiplied by the initial base concentration. In the next question, I'm trying to make a different conversion question. So let's see the different conversion question. If pH is given as 12.22, what is pOH? We said in order to find the pOH from pH, just subtract. So 14 minus 12.22, that's equal to the pOH value. And then in the next question, find concentration for all species at equilibrium for dissociation of a weak acid. I have a sample of HOCl, 0.0720 moles in 100 ml solution, and I have given AKA. I need to find the A minuses. So I need to find the H plus and A minus. So if this one has the composed HOCl, it will give me H plus and OCl minus. So these two are similar, as we said. Many times they are equal. To find this one or this one, how do you find it? Just by the concentrations. But I initially don't have the concentrations. I have only the volume and the number of moles. Concentration equal to number of moles is 0.0720. And the volume is 100 ml, so must change it into decimeter cube. So 0.720 divided by 0.100, that's equal to 7.2 multiplied 10 to the power of negative 1. This is the concentration of HOCl. This is the first one that we found. It is 7.2 multiplied 10 to the power of negative 1. And this is not a strong acid. This is not a strong acid. And since it's not a strong acid, you cannot just say it's equal to 7.2 10 to the power of negative 1, 7.2 multiplied 10 to the power of negative 1. You have to make the ice table. What does the ice table tell us? It tells us if initially you have this one, it will decrease and this 2 will increase, and this will equal to 7.2 multiplied to the negative 1, and this is x and this is x. So the Ka, or the weak dissociation constant of the acid, is equal to x squared divided by the initial concentration of the acid, which is 7.2 multiplied 10 to the power of negative 1. So x is just equal to the radical of these two, Ka multiplied by 7.2 10 to the power of negative 1. That's equal to Ka, which is 3.5 multiplied 10 to the power of negative 10, 8 multiplied by the 7.2 10 to the power of negative 1. That's equal to 1.59 multiplied 10 to the power of negative 4. And as we said, these two are the same. So H plus and OCl minus equal to the same value. Don't forget what we have said. If you want to find the values, you can just do like that. So OH plus or H minus equal to the radical of the Ka multiplied by the initial concentration of the base in case of Kp and initial acid base concentration in case of Ka.